So in the previous videos, we looked at components of vectors, and the components that we looked at were the I and J unit vectors. And they were very convenient components to use because they literally run along the two X and Y axes that we're very familiar with. But often it's important that we not just find the unit vectors in terms of the axes, but it's sometimes useful to know what the unit vector is in the direction of the vector itself. And so that's what we're going to be looking at to do today, is idea of a unit vector in the direction of the vector rather than in the direction of the two components I and J. So if we want to find the unit vector in the direction of A, we use a denotation called A hat. And you'll see it literally looks like the vector A, so it's a vector. You'll notice that in the typing it's always in bold, so I can't write in bold, so I use the tilde to indicate a vector. And then we've got the hat, okay? And so we call that A hat. And what that means is, so if I draw a vector, so if I pick out, just create a vector very quickly, Y, X, sorry, thinking about three things at once here, and I create a vector, so there's my vector AB, okay, oh, I don't know why I did that second arrow, I'll just get rid of that. There's vector AB along there. And I want to know what the unit vector is in that direction. Okay, so its direction is some way up that way. Sort of just put my cursor on. So it's some way in this direction here. Okay, so I want to know what would be the unit vector in that direction. So unit is like one length, so 1 unit long. Now, the difficult concept to get your head around is what is this idea of a unit? So whenever we've done mathematics, we've always had sort of fairly standardized units. So we've had things like centimeters or kilograms, and they've been units. So if we're talking about a length, then the standard unit is a meter or a centimeter or a millimeter or so forth. Okay, and they're compared to something. But when we're talking about vectors, we don't really have a dimension length that we can call on. So what we tend to talk about is a 1 unit of length along that vector. And so I think what we'll do is do an example to try and illustrate, well, how does this actually work? So there's an example of a vector, 3i plus 4j. So the first thing we'll do is just draw that vector. So let's do that. So we have a Cartesian plane. And if I was to mark it on, so y and x. Okay, if I was to draw that vector, okay, I would go 3 units along I and 4 units up. So I would have that vector there. So that would be my vector A in that direction. It's 3 units along and 4 units up. Okay, so the first question is, well, what's a magnitude of A? Well, that's a pretty easy calculation. We've done that already. Okay, so we can, using Pythagoras, we just have a quick one, and we've got 5. So we know the magnitude of A is 5. So it is 5 units long. So my question then is, well, how long is 1 unit? So if this vector is 5 units long, what's the 1 unit equal to? Well, it's going to be a fifth, because it's that length of vector divided by, so 1 unit, it's 1 whole vector long, divided into 5 units. So it'll be 1/5. So the unit vector is going to be 1/5 long. But we've already discussed the idea that a vector has to have both magnitude and direction. So we've got the magnitude part. So the unit vector is 1/5 of a unit, is 1/5 long. So the unit is 1/5 of something long. But what direction is it? Well, what direction is our unit vector going to be in? Well, it's going to be in exactly the same direction as our original vector. So how do we know what the direction is? Well, it's simply going to be the same as the original vector. Okay, and so we don't need to do this, but if we wanted to think about it, we'd actually have, so the unit vector would be 3/5 of a unit in the x direction and 4/5 of a unit in the y direction. And that would be my unit vector. And if I have 5 of those individual vectors, so 5 of these individual vectors, I would have my original vector back. Okay, and they're all going in that same direction. And if we think about that, so if I go 3/5 of a unit across and 4/5 of a unit up, that'd be my first unit vector there. And then I'll just repeat the process, 2, 3, this is not to scale obviously, 4, 5. So there, 1, let's do it in different colours so you can see them, 2, 3, 4, 5 unit vectors along. And so the calculation is simply 1 over the magnitude. So we know the magnitude is the total length, so 1 over that will tell you how much 1 unit is long, and then multiply that by the original vector, because that defines the direction along which the vector is travelling. And that's how we calculate a unit vector. Now, applications of that won't become obvious until we get further into vectors. Okay, so I just wanted to look at the idea that not only can we define direction in terms of our x and y axes, so our I and our j components, but we can also define vectors and the direction in terms of the unit vector in that direction. And as I mentioned, the applications of this will become clearer as we work our way through. At the moment, we're just looking at some different concepts. So, good luck.